Hello everyone. In this video, and as a continuing part of this series, we are going to make a Linux service send email. And so I've got my notes here, and few discussions like this can start without mentioning Jamie Zawinski and Zawinski's law, which states, that goes over here. Every program attempts to expand until it can read email. Those programs which cannot so expand are replaced by ones which can. So this is not particularly reading email on this video so much as it is sending an email, but we'll get to reading email. And then the next thing I want to point out is how the mechanism to do this, called the SMTP-lib, is built into the Python standard library. You'll find it here as part of the standard Python documentation. I'm looking at 3.10s, but this has been there for a long time, and there's many other ways to send email, but this is the most popular and long-running protocol to do it, and it works, so we'll be doing that. And the next thing is to actually show it working in Jupyter Lab, and to say why Jupyter Lab. Here's Jupyter Lab Desktop, which is the same thing as Jupyter Notebooks. This is just the standalone version from inside of a, I guess, an Electron app. It's a lot like a browser. I have it in full screen mode to try and get the whole program showing here top to bottom, which I have been able to do. And then there's really just one import that makes the whole thing work, SMTP-lib. Oh, and I develop it here in Jupyter Lab because as I go, I can do things that let me run the code one piece at a time. I could do that to sort of describe what's going on here. I kind of left those spaces, so why not, right? So we import SMTP. Well, I'll do a kernel restart, restart kernel, and clear all outputs. Restart. So all these numbers go away, and as these code blocks execute, you will see that number appear, the order in which things were executed. So I just imported SMTP-lib, and I created a multi-line message, which I have kept to a few lines, but there are enough to show you that the email is handling multi-line messaging and preserving my line wraps. There's issues here. We'll discuss these things in more depth if people are interested. Now, this next line here parses that message. It replaces the line returns with carriage return line feeds, which is a Windows type thing. Someone in my messages, someone in chat the other day in a video asked about what about the difference with PC text files? I'm like, yeah, you still got to deal with it. This is one of those places. You can see the variable name I changed from message to PC message, implying that these carriage returns that come at the beginning of every new line are in fact a PC type of thing. And then I have two with open commands. One is for the from address, and the other is the to address. And then I do a little bit of parsing here, which is very typical after loading a file using with open. You can read the whole thing in with read lines. Poop reads it in, and so for each line I actually strip off a the carriage returns at the end, and yeah. Okay, so these files are private. I can't show them to you, but I have some others set up which I can show it to you. So I go over here, and you can see I actually did the work. I CD'd into my practice directory. I looked at the files that were in my practice directory, and then I copied my original mail from to mail from example, and I copied my original mail to mail to example. So we should look inside of those. I vimmed them before, and I can repeat those commands. So I'm vimming the mail from example, and you put whatever email address you're mailing from on the first line, your from address, and on the next line you actually put your app password. And so we're using Gmail to do this, and it's probably a good idea these days, right? If you're going to lean on someone's email infrastructure, you could do a lot worse than Gmail. Now, one of the criteria for Gmail, because security is locked down so much, is that you need an app password. So what you do is you go to this address. You can really just Google security and it'll be the first one, but it's my account security, and you get yourself an app password and you put it on that second line. So it's your email address here and then your app password here from Google. And I in fact have that page loaded here to show it to you. This is the email address I'm sending it from. You have to turn on two-step verification in order to get an app password. I'm not going to click into that. Probably wouldn't even show it. I think the way these security things work, it won't show it. You can delete it from there, but it won't show it again. But you get yourself an app password, and then you put it in this location. And so much for the mail from.txt. Now we'll look at the mail to.txt. And you just put a list of the ones that you're sending it to. You just stack them vertically. You can see I put a real email address in on this last one because I will be demonstrating sending to one of my real email addresses. This is one I keep around for, I guess, uses exactly like this. And so we go back to the notebook and we run that. So now we just simply have a variable named email, a variable called password, and a variable called mail to, which is actually a list. And then this next line does the server setup, right? And even logs into it. By this time, you're logged into the server. You tell it the address for the SMTP server, the protocol it's going to use, and a bunch of other stuff that gets it started. So we run that, and it runs successfully, right? Accepted. That's a good output there. And then we send the email. We create the body of the message, which blends a lot of that stuff together that we've been doing. There's the mail to, there's the email, there's the message. Oh, look at that. I don't even need the PC version of the message. So I am going to refine this. This was not necessary. We did not need to turn it into a PC style thing. And in fact, I'll rerun that just to satisfy that fact. So message is populated, but PC message is not used anywhere else. I am refining this program before your eyes. But we do have to put a carriage return line feed here before this message because there need to be two spaces between the to and the from and the subject and the body of the message. That's how it knows where it begins. So anyway, we run this and we send the message. We'll do a before and after. Look, there's no unread emails. We run this. How much patience do I have? There it is. Send email, right? Email has been sent. Mission accomplished. So once you develop a program like this, a very typical practice. Now I have a keyboard shortcut for restart kernel and clear all outputs. It's so popular to do. And then you drop your cursor into a box where you want to start. You hit the escape key and then you hit Shift M, Shift M, Shift M, Shift M, and it just blends all those boxes together. It merges those boxes. And now you can copy that code in just one go like that. See that? Isn't that nice? And then you can go over here to your servers. Now you'll remember from my work on the other day, and we'll get out of this. We don't need to be in there anymore. You'll remember from my work from the other day, I went into the container Munchkin, right? So on my machine, I'm running Linux containers. You can see my Linux containers here. Right now, Munchkin is running, right? So, and you can see on my host machine, I'm usually in Helix at Lunderwand, right? So that's my host machine. That is the top level Linux machine that's hosting the containers. That's where LXD is running and where I issue my LXC commands. And for those who weren't in the videos yesterday and for the past few days, you'll know that I have an LX alias, which actually just does an LX list fast, right? So when I'm showing it like this, when I just type LX, I'm really actually doing LXC, LS minus minus fast. Now I won't do it now or it'll fill that screen too much. You get the idea. So we're going over into Munchkin, which is my only container right now that is running. And then I have 2 terminals connected to it from yesterday's work. These are still left over from yesterday's work. And you'll recall there's a service running. I'll clear the screen and I'll do, well, I can do a few different things, but I think looking at screens is probably the best way to do it, because now you know I use this program called Screen, which is very standard in the Linux world. It's part of the GNU command sets, except it's not included by default with a new container because it's a server. It's a little server. And using that little server, you can host these terminal screens, which you can run your Python scripts through when you're running a service, a Linux service, so that you can watch it by going Screen, reattach to Pulse. And there it is running. And this thing has been running. I don't have caffeine running on my system now, so it probably went to sleep when my laptop went to sleep. But13 seconds, a new date time pulse is written out. Oh, and there it's really useful. You can see there's been 1,392 pulses since yesterday's work. I've just had this running in the background. And I can show you the log file output, which basically contains the same thing, except it doesn't have the hello world. It's Control-A-D to detach from the term. Well, why detach? I have 2 of these things running. I can just go over to this one, and then I can tail tmp pulse underscore scheduled.txt. Oh, look. Yeah, it's the last 10, right? 1398, 1399, 1400, 1400, right? So every time I tail the file in my log file location, you can see the last 10 entries. Or you could vim that same thing and see the whole file. Now, it's not really occupying that much memory in my system because, you know, as these things go, 1,400 lines is nothing, even sitting in memory as this file. I'm in no real danger. If I did this every second or so, we might start to get into the territory where, you know, you got to be careful. But you get the idea. The service is running. It's running quite well, right? And so you can watch the service running with a screen program, or you can look at the log file output. It's a wonderful way to manage this stuff. And it is that program that's doing this where we are going to insert this this email schedule, but you know, not nearly as frequently as it's running here. I'll probably send it every minute so we can just watch and see an email happen, and then I won't keep it running all the time, so I don't fill up that address with emails. Okay, so CD, where I do all my work, that's always home, GitHub, and then the repo name, which happens to be Pulse right now. And then I'll clear, and I'll ls. So the only files in here are the original Pulse file, and then the one that has the new work in it. So just as a reminder, the old one is just a while true busy loop where every second it just did the writing out of the timestamp, pulse, heartbeat, whatever, what have you. It would both write it to the screen and then it would write it into the file every second, right? And so yesterday's work is we changed that to a much more intelligent approach where we import a schedule package, and then instead of just a while true busy loop, you can see there is still a while true busy loop, but instead of just doing the writing out the heartbeat here, we run anything that's scheduled. So every second it says, do I have anything scheduled to run? Do I have anything scheduled to run? Do I have anything scheduled to run? Now that might seem pretty busy to you, but it's not. It's not. Modern computers stopping and doing a check like that every second is no problem. If you really wanted to, you could change that to some other thing than every second. But with the modern power of computers, it's a decent place to use that capacity. And then the pulse, all the pulse stuff is actually moved in here as opposed to right inside the loop. It's called a function name. And then that function name is scheduled here every 5 seconds. Schedule every 5 seconds pulse. And there's a little bit of order sensitivity. I discovered that I had to define my functions above where I had to define my schedule. And then it runs the schedule down here. So that's sort of the setup work. And we're going to be adding another scheduled item every minute to do an email. But before we get to that story, we have to tell the story of just doing it in the first place at all. So we quit out of Vim there and we go Vim, I guess I'll call it SendMail. Now that's also the name of a very popular program in the Unix world, but it's not going to collide. I'm keeping it in a directory here. It's never going to see, if I even have the main SendMail Unix program on my system, it'll never see it. It'll never have anything to do with it. So I like that name, SendMail. It's very descriptive. So I'm going to use it. So we vim SendMail, and then we go I for insert mode, and then we go back to Jupyter in this process, this high-tech process of copy and paste. Now, clearly there's about 100 different ways to even accomplish that. There's NB convert. There's all kinds of things people will do to get a file like that over here. In fact, I'll be demonstrating another way because some of the required files here, I won't be copying and pasting, or I would be showing you my email app password credentials. You don't need to see that. So this culminates quite a bit of interesting work from the other days because I'm going to be moving that file into this directory using the data location. So you'll recall, if I quit out, let's see. I'll use this one over here, Control A-D to detach. We're in the pulse directory here, but if I CD to my top level and do an LS, you'll remember I have this data location, which is mounted on all my containers and is mounted on my Linux host system. It's mounted on my Windows system. It's mounted on my, home cloud container server. So data is everywhere. Data everywhere, and not a drop to drink. So I'll go to one of my available virtual desktops. And for those not familiar, I'll use this one here. For those not familiar, virtual desktops are really cool, right? I'm showing the Windows way to sort of show the overview, but generally you just switch left and right like this, which is identical in the Macintosh and which is identical on the GNOME desktop. So this is generic. This way I work is not a Windows 10 thing, although it is living quite nicely under Windows 10. They have a great implementation. But once you learn to work this way, virtual desktops are everything. You'll never need an external monitor. Never. There's always edge cases. So anyway, I just do Windows key E for Explorer. And then I find my data location, which on this machine is mounted as my D drive. I'll push that over there. And then I'll open another Windows Explorer and push that one over here to the right-hand side. The old days of the file explorers like Norton Explorer and FileMan under the Amiga. There's so many things that made this kind of thing easier, but Windows is good enough these days. ArrowSnap makes it real nice. So we're going to be moving that file into data. I guess I should have put data over here as the destination and then the source over here, because the source is going to be coming out of my GitHub directory, out of my practice directory, and then there's going to be a couple of files there, which are my from and to. It's this one and it's this one. And I just copy them over into my data location. And just like friggin' magic now, it's available to my container. And from that container location, I can move, mail, everything, because wildcards work in this sort of stuff, into, and you remember, As long as you're using these very conventional paths, you always know where everything is. I put everything in GitHub relative to home into a directory. It's not practice, it's Pulse. And you can use the directory name here, and it'll copy everything that is mail asterisk into that location. So if I cd into ~/GitHub Pulse, you will now see that those files are in location, and I can probably try and run that send mail from here. So let's do a before and after. I go back to the inbox of this location, and I delete this one so that there's no confusion. And then I will be quickly zipping back to that location after I do. Okay, so we're not in the virtual env, and when you're not in the virtual env, you have to give some very full paths, right? I can't just type Python. It won't find it. I can't even type Python 3. Oh, I can. Look at that. Ah, very nice. Okay. Well, live and learn. So, from this location, since I can get to Python 3, I don't have to worry about long paths at all. I can test this by just going Python 3 space sendmail.py, enter. Boom, email sent. We go back here. Boom, sending email. Now we are presented with a rather interesting dilemma here at this point, very related to the Huey work I'm about to do. So you might go, why are you doing this, Mike? Why are you going through all this effort? It's because it's what I need to do for my day job. This is all the same kind of work as my day job. And so now you'll notice when looking at this mail program, there's no functions. Why should there have to be a function? I just don't see the need. So as a bonus, I am going to move this into the scheduler now without turning it into a function. Now, this is some fairly advanced stuff. Everything so far has been really on the simple side. It's only this much code to send an email. Can you believe that under Python? Using standard library, I didn't have to pip install anything. All I needed to do is get an app password so that let's see where it's done. So that this step, so that server.login has an email and password that will actually work, that won't be kicked back. The locked down security context to fight spammers is so tight around the world now that pulling off this little piece of magic is actually a lot more difficult than I just made it look. I know the magic combination of things, which is use Gmail as your mail server, so that means all your mail froms is going to be from a Gmail address, right? There's always a gotcha or a downside, but when you lean on massive global infrastructure, you pay the price. So by using a Gmail here and then a Google provided app password here, and there's one more place, the protocol of how you send it, right? So you make these connections to the server, and protocol 587 here under SMTP. So SMTP is really the protocol. 587 is something else. I'm not sure if it's ports or whatever. But this magic combination makes it work. You just saw it. However, I'm not going to turn it into a function. Not going to turn it into a function. Well, when we look at our Pulse schedule, it works on functions. You schedule functions. You don't schedule external files. And that is a significant issue. That's a significant issue because a lot of things you're going to want to schedule are external files. Here, under this primitive scheduling system I'm cobbling together, and also under data pipeline systems like the Huey one I'm going to be moving to. A lot of times, if it's not, how do I say this? Okay, so there's two great APIs for doing things to a function. One is just listing them out, right? This is just sort of listing them as a list, schedule this schedule this. But the other great way is that once you've imported something like this, all the capabilities are also at your disposal, and new features might have been added that are just sitting there unbeknownst to you. You could use a different API and you could decorate it. You could decorate a function with something having to do with, it would be schedule dot something, and then it would be some, something like this, every whatever. I'm not saying this is the API for it, but when you put a decorator on a function like that, by things that support it, it eliminates the need to do it this way. So we're going to be going to that other alternative API probably quite soon in Huey, but not in this video. But you need to know that there's alternative APIs. But what I'm going to really try and accomplish here is schedule every 1 minute, do send email, right? So that's not really going to work right now because there's no connection between the send email program that I just wrote and here. And even though it's sitting in the same directory, I could save that and it's not going to do it. So let me just go ahead and save that. And this is the program. We're not really going to need to show the program anymore, but we can screen reattach to Pulse, and you can see that this is going to continue to run just as well as it always did, even though I added this line, because this isn't in memory yet. This only happened on the drive. So unless this service is restarted, it's going to keep doing what it did in the past, which is absolutely fine. But we're going to do a little bit of changes that I documented in my journal, and hopefully I can pull this thing off, right? So the whole file right now is only that big. The whole scheduling thing, the whole writing of the Python service that this series of videos has been about is just this one file here, plus another file over in etc systemd system that says, hey, this file here is a service. Why don't you run it? And make sure it's running every 5 seconds, a few things like that. So the two files together make it a service. So how do you run an external file as a freaking service in this context? Well, I alluded to it in yesterday's video. And I could show you that where I alluded to it, or I could just go and do it, right? I'm just going to do it. So I did all this other stuff here that I wanted to do in the journal. And I was going to cut the video there because it sets the stage for the next step. But I'm on such a roll and we're only a half hour in. Why don't I go ahead and do it? So I happen to know that it's the much maligned popen. There is no reason to use popen to run one Python file from another because you can just import it or make it a native function in the same file. Well, this is one of the exceptions. This is one of the places where that is not necessarily true. So we have, you're going to see me turn off these line indicators. I have this lovely way to, like, I could do this and then I could go J is up, so I can do 3J. Oh, I did it the wrong direction. 3K, and highlight that, and then do a yank, and that's in my Vim copy buffer, and that's why we have this lovely ruler here thing on the side, so that if you wanted to do that, you could highlight any line, and then J is up, K is down. So if I wanted to go down to, say, here, I could just type 16K, right? Did I do that right? I don't even know. But that is why that relative numbering system is on the left-hand side. But I think I went the wrong direction. I went up. J is down, K is up. Yeah, I went 16 lines up. So I don't use it that much. It's more aspirational than it is in use. I'm going to try and do that more often. But I need to copy into the system's copy-paste buffer, not the internal Vim copy-paste buffer. And for that, I turn off relative number. I just toggle it using the exclamation point at the end. Ooh. Plural? No. I have a keyboard shortcut for this, so I don't really... Oh, yeah, it's set. So I have a keyboard shortcut for this, so that's why I struggle sometimes when I do this. So it turned off the relative number, but I also need to set just number off. So I toggle off number, and I toggle off relative number. Now I can copy these imports fairly easily. We're going to need all these imports. I could explain every one, or I can just do this and you can see it working. So let's add a few more imports. I can do it here to demonstrate it there, but I think, oh no, I couldn't. This is not an inside the email program thing. This is inside the scheduler. So I'm going to get rid of this one. I'm going to quit. And I am going to copy pulse, just to keep our work nice, copy pulse scheduled to pulse sendmail.py, because this one will incorporate sendmail. Now I can vim pulse sendmail, and it will not interfere with any of my other work. Not that it would stop that service from running because it's in memory, but it will keep records of it so that, you know, I can show in later videos the different stages of this thing. And so this is where the extra imports need to be done. And a lot of people will follow very stringent PEP 8 standards here. But honestly, I just feel better about the code if it follows a very nice waterfall pattern here, so that you can just see the lines getting longer. And there is an external, you know, a pip installed package here that's getting imported before other things. So pep8ers are going to go bloody murder, and I'm going to be like, so what? And then we've got all our imports done to have our magic fairy dust that needs to be sprinkled in to make the next step work, right? And the next step is going to require, instead of a function that has the code inside of it directly, like this does, see how this is all native Python. Everything that's being done here is being done right inside that function, not in an external file. There's no reason you couldn't make things happen in an external file, and I have prepared that in my journal because I thought I was going to do this demo the other day. That is this thing here for running. Now you'll see this running has all these line wraps in there, which is really weird. That's to abide by PEP 8. And this was all one really long line when I started out, but I used the black uncompromising code formatter to do these proper line wraps. In fact, I probably still have that in Jupyter here. I'll turn off simple mode for a second. Give me access to my other tabs here. And it's probably this untitled. No, it's probably this untitled. Yeah. So if I do an undo there, this is the long line that actually started out as that command. And then I installed NB Black and NBDev. I installed both of them because I use them, but NBDev isn't being used here necessarily. But NB Black is being used here. I use the Jupyter Magic to load external plugin NB Black, which is now available, or Lab Black they call it. And then when you run this, it just magically reformats it, and that's the one that I copied and pasted over there into my journal. Well, I can copy and paste it from here just as well. And that can go here. This is as good a spot as any above where all the functions are defined. It didn't go into my operating system copy buffer. You will find that doing copying on Windows these days, especially between the Windows subsystem for Linux and the host, especially between the Linux subsystem for Windows and the Windows machine itself. Oh, this language and labels are terrible. You sometimes have to do multiple copies in order to make it actually work right. So I've got this run command here now. This lovely, lovely run command. And that opens the door now for bringing in external files, because there's that popen that can load external commands. So you just send to this run command some command and the current working directory. CWD stands for current working directory. It defaults it to none, the way Python functions are written. When you have a parameter of a function that equals something, that's what's going to be used if nothing is provided when you send a command to it. So this defines the run function. And so what are we going to run? Well, I have another example of that in my journal that I prepared. Oh, this is the old one. This is very similar to the old one. And we are going to be making one pulse right here. Okay, so we take this into our copy buffer and we move over here to where our code resides, and we make it as an alternative to, it's not an alternative to pulse. It was going to be an alternative to pulse. That was my original plan for this piece of code, going from a pulse that actually, had the scheduling bit to a single pulse. But this now really is a single pulse. It just writes out a single pulse. The whole looping bit that makes it go over and over is handled by the scheduling down here. So instead of one pulse, the identity of this thing is going to be changed to send mail. And you will now see right off the bat that that original plan to do every 1 minute send mail now actually has some sense to it, because every minute it will be running the send mail program. It will be using where Python 3 is located, Python executable path, right, which I set here in the pyx variable, and that will use fstring replacement to put that there. So it's going to be sending to the Python executable the full path to the file. So this is the file name, but I also have it broken out with the current working directory, so I can reuse that current working directory value here. Otherwise this would be a little bit uglier to look at, because this would be repeated both here and here. And so why do that if you can just use a variable? So now we have a schedulable external program that we just tested, and we saw that it works. We know it works. That's how this very latest email has appeared here. And I will delete that out, and we will put a little command output in here so that we can actually see that the send mail program has run. In fact, there's going to be its own output, so I'll just do a before sending email. And if you wanted that to go into the log file, I would just do a with open, pulse email. Oh, okay, yeah, this is going to be a different pulse. Pulse scheduled, pulse email, send mail. Send mail, pulse send mail is the file we'll be writing out to now. And so when we restart the service, it's going to be an entirely different file out here that it's going to be sending to. And it'll do it every 1 minute. We'll see its output both at the beginning of running the function and the, it's actually going to be executing this command, which has its own output that we saw over here when we ran this. I'll run it again just to appease our curiosity, right? So email sent and this stuff here. We'll delete that again. And that's the result we're looking for now on a scheduled basis. And after 10 lines, because, every 10 seconds, those outputs occur, we'll know that the email should be sent or it will exit out. So without further ado, let's get the whole program showing here so you can see what it is that we're really doing. And with this much code, this is really all the code there is. And I could make it even shorter. This is a lot of excessive line wrapping in order to abide by PEP 8. But we now have scheduled every 1 minute that email, pulling it from an external source because the run command, because this run command is using popen. All right, so without further ado, we can run this directly before we run it as a service. So you'll remember the service is still running in the background, but that shouldn't keep us from right quit Python 3, because I discovered I can just do it directly. And this is pulse.sendMail. Now, do expect things to go wrong, because on the first run, often things go wrong. And it's not going to work because I pip installed schedule from under the virtual env. So we'll source Py310 bin activate. All right, so now, oh, that's an interesting issue. Will that run as a service that way? Yeah, because it's schedule. It wouldn't be working over there if it didn't. So anyway, it might have to do with full paths. So the pulse service has started. That's 1. That's 2. This is 30 seconds. 40 seconds. That's 50 seconds, and this will be 60 seconds. So let's get our before and after set up. This is a little optimistic because if there's an error, it would be showing up over on that screen. So we'll just sit here for a second and be optimistic. And if it doesn't show up right away, I'll go over and see what the error is. It should be here by now. There's an error. Oh, sending email. Oh, see, I saw the error pop up. Log not defined. Okay, I'm doing a log info thing. Well, let's see if the email, it still happened. It just has an error in there. I'm going to take out the reference to the log, and we'll do that test once more, and then we'll move it over to the scheduler, over to the service, over to the real service. Okay, log not defined. So we'll just vim pulse send mail again. Oh yeah, log info. I'm doing that as a matter of course in the run thing, and we don't really need to. But it could be nice to print it. That'll just send it to the output screen. That's how you get the output from these programs. There's a lot of interesting stuff going on here for line and process standard out, line equals strip, print line, standard out flush. Boy, I could talk you through how I developed this little bit of magic here, or I can just show it again and show it to you working. Python 3, pulse send email. Pulse service has started. I could probably schedule it quicker, less than every 1 minute, in order to get to the payoff more quickly, but here we are. And once this works, we will then turn it into the actual Linux service. We'll replace the reference to pulse underscore, what was the other one? I was demonstrating something else. Schedule. Pulse underscore scheduled is currently being pointed to. And we'll replace it with pulse underscore send mail. We'll also wait long enough to make sure that the error doesn't occur here. So that email, we'll do a before and after real quick, right? There is nothing from the Pipulate email address here. Sending email. It's email sent. Bam! All right, it's ready to become a service. Control C. All right. Control L to clear. Sudo vim /etc/systemd/system/pulse service. Change reference to the scheduled file to send mail. Right, quit. Sudo system ctl daemon daemon reload. You should see this get nuked, right? There's not going to be, oh, look at that. Oh, it keeps it running? Can it really? No. Ridiculous. So I'm going through my learnings here too. I err on the side of, precaution. So I've shown you in the past that once you do something like this, you could sudo systemctl pulse restart. That is one option, but watch, I am not going to hit the return key to restart the service that way. We are connected in, we are logged in through its screen terminal, right? So I can just Control C here and let systemd do its thing to relaunch the service, which is functionally the same thing as a restart. The pulse service has restarted. Now, we'll do again our before and after. Make sure there's no email here from Pipulate. We'll delete that one. And we go over here and we wait for it to get up to that point and watch for the, you can also see right away, it's updating the log file pulse_sendmail instead of pulse_scheduling. So right off the bat, I know it has loaded the new and correct Python py file, you see. And so in a moment, you will see a Linux service that is monitorable and which is able to send email. If it exits out because of problems, it will automatically restart. Email sent. Go over here. That, my friends, is an email sent from a Linux server. From a Linux service, on a Linux server, running on a Linux container, running under the Windows subsystem for Linux, under Windows 10. Ta-da! Yeah, if you like this stuff, if you like learning Linux and Unix-like operating systems in a more fundamental way than all this web dev stuff that you're going to be led to, you're going to be led to web dev over and over and over as your starting point for learning technical stuff. It's not good for you. It's not good for you to dive first into web dev. It has to be put in context. This is the context. It's one united world under systemd. In case anyone has missed the point, things change very, very, very slowly in the Unix and Linux world. A little less slowly in the Linux world than in the Unix world. And that's great for your knowledge and know-how and career and obsolescence resistance and future proofing. But every once in a while, things do change. And the way it changed recently is the formalization of something called systemd. What I'm showing you here has a great deal to do with systemd. And it was written by a guy, by the way, who is very controversial, who started out by copying LaunchD from Apple. So this guy here copied a lot of this systemd stuff from Apple, and for lack of anything else and being good enough and everything, it got formalized and adopted and the standard across nearly every Linux distro. It has even hit, surprisingly, the Arch distribution, which used to be a holdout. And there's only a handful now that are holding out against the older system. So if not Systemd, then what? Well, it was called sysv. It's not System 5 Release 4. You will learn a lot about, there's two different things that are similar. There's Unix System 5 Release 4 from AT&T that really unified all the vendors and made Unix, the POSIX standards. But then there's also sysv, which is an init system. It's just a script that runs, when a Linux system starts or a Unix system starts, really. This goes back to the days of Unix. And I think it was, it was originated from Bell Labs, but you had to learn Bash script. You had to learn, Unix script, which is a lot harder than just editing a text file that looks like, yeah, I didn't have to restart it. Creating files that look like this is what's replacing having to learn Linux script or Unix script or Bash script, which is not pleasant. When I showed you, when we do source activate, it's running one of those files, which is a lot more complicated and messy than a simple configuration file that links to a Python file where you know what's what, right? You go into this program, it's not complicated, you know what's what. And all this gives you the Systemd API. You can now stop and start and restart and check the status on this. So things change very slowly in the Unix and Linux world, but when they do change, sometimes the change is really big and worth noticing. And in this case, it's a bandwagon worth jumping on. And by jumping on this bandwagon right now, you will be ahead of everyone else in almost the world, because no one knows this. This is the early adopter time. And I assure you, this is the standard. It's the adopted formal standard. It's part of every Linux distro. Now, the other part of this picture that I'm using, which is the container technology, is not really as formal as this, but it's on its way to becoming that formal. So anyway, that's a few extra bonuses I threw in on this video. And because I scheduled that thing to run every minute, you'll probably find there's 4 new messages. There it is. Message, 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 message. Talk about a heartbeat. If I sat here, more would appear. Now, I'm going to change the duty cycle and everything because there's no reason to keep this. It'll certainly remind me if I keep this service running by accident, I'll know it. Look, there's a new one that appeared, but I'll only know it from this email address that is not my main one. So I'm rambling now. I hope this was of value to you. Thanks for joining me. I hope to talk to you soon. I hope you're following this and getting all the value out of this that is there to be, won, and don't forget to subscribe, thumbs up the video, hit the bell for notification of live broadcasts, and all that happy stuff. Talk to you soon.